morning, class.
Good morning.
Today we are going to learn about friction, as well as the application of Newton's second law and kinematics to real-life situations.
What's friction?
Friction is any force that resists relative tangential motion.
What?
Okay, friction is a force from a surface that goes against an object's motion on that surface. Get it?
Yeah. I think so.
Good. So let's try a practice problem.
A hockey puck of mass 0.17 kilograms is sliding on a frictionless surface at 10 meters per second. It leaves the surface and moves onto a sidewalk which has a coefficient of friction of 0.42. What is the acceleration of the puck once it slides onto the sidewalk? And what is the distance the hockey puck will travel?
Jasmine, what should our first step be to answer this problem?
Do we draw a free body diagram?
No, that's correct. So, where do the forces go?
Okay, so I think the force of gravity goes straight down because it always goes straight down, and since the puck is on a flat surface, the force normal is going straight up. And I think the force of friction is going to the right.
Well, you're right about gravity and normal force, but friction should not be to the right. Friction is always in the opposite direction of the object's movement, and the object is moving to the right, so in this case, friction is directed to the left.
Okay. Do we sum the forces or something?
Yes, according to Newton's second law, the sum of the forces in a system is equal to mass times acceleration. Now, Jasmine, can you come up to the board and solve this equation for acceleration?
Well, I guess I could try. Watch where you're going, bud. Okay, so f of y is equal to f of n plus f of g.
Actually, that should be a minus sign because force of gravity is down, which is the negative direction in this scenario.
Okay, so since there's no movement in the y direction, we can set this equal to 0. So once we add force of gravity to both sides, then we have f of n equals force of gravity. And for force of gravity, we can plug in mass times acceleration due to gravity. As for the force normal, f of n equals f of f divided by mu. So we can plug that in for force normal. So after we plug in f of f over mu for f of n, we can multiply mu to the other side. And now we can sum the forces in the x direction. Okay, so when summing the forces in the x direction, f of f equals ma. So then we can divide m for both sides and have f of f over m equals acceleration. So now we can plug in this equation into f of f. Once we plug in the equation here into here, we see that everybody brought mass to the party.
Everybody brought mass.
Okay, so we can cancel these out. And then we found our answer.
Wow, good job, Jasmine. You can take a seat now.
Thanks.
Now all we have to do is plug in our known variables. Mu equals 0.42, and acceleration due to gravity on Earth is always 9.81. So once we put those in, we get acceleration equals 0.42 times 9.81. And Jasmine, can you put that in our handy-dandy calculator? Well, Jasmine, you did a great job, but you only forgot one thing. Force of friction is negative in this case because it's going against the object's motion. So when we get all the way down here, our equation is going to be acceleration equals negative g mu. And then when we plug these in, we get the final answer. It's that the acceleration of the puck, once it gets onto the friction surface, of the sidewalk is negative 4.12 meters per second squared. Now this checks out with our units because coefficient of friction does not have units, and the units for gravity are meters per second squared. And of course it's negative because the object is slowing down when it meets friction. So now we have solved part A of the problem. Next question we must answer is how far did the puck travel? What can we do to answer this?
I think we should use kinematics.
Yeah, that will work. What kinematic equation do you want to use?
Well, since we don't have time, we could use the third kinematic equation, which is velocity final squared equals velocity initial squared plus 2 times acceleration times the displacement.
Now let's solve for displacement by subtracting initial velocity from both sides.
Cool!
So we did that, and then we're going to divide both sides of the equation by 2 times acceleration, and now we've isolated displacement. Now, since we know displacement is equal to final position minus initial position, we can just put delta x in these parentheses. And all we have to do now is plug in our known values. Of course, we know that v final is equal to 0 because we want to know how far the puck has traveled when it stops. And so when it stops, it's going to have 0 velocity. So we're given 10 meters per second as the object's initial velocity. And we also found that acceleration equals 4.21 when we completed the first part. So after plugging this into our handy-dandy calculator, we find that the puck will travel approximately 12 meters by the time it stops.
No holding hands in class.
Hey!
Ow, I scratched myself.
That's what you get for PDA. Good morning, class.
She bumped into the table. It rolled as you said that. And since there's no direction in the y